guys, this is Mr. Brown, and this video is going to be on 4.3 trig functions on the unit circle. What we're going to be doing today is talking about trig ratios when you're given an xy coordinate, identifying reference angles, filling out a unit circle, and then using that unit circle to find trig ratios. All of this stuff you guys have done in the past, so it's basically a review video. Alright, so our trig functions, our basic SOHCAHTOA ones plus the reciprocals. Take a minute, pause the video, and copy these down. We're going to need these for this lesson. Alright, so first example looks like this. -3,4 is our point. We want to come up with our 6 trig ratios based off of that point. The first thing that we're going to do is to graph this point. So just graphing an xy point, you've done it 1,000 times. There's our point 3,4. From that point, to review, you're going to draw a line back to the origin, and then you're also from that point going to draw a line straight down to make a right triangle, and our angle that we're concerned with is in that corner. The lengths of this triangle get a little weird because we're saying that the bottom side is now -3, and then the height is the y value which is 4. We can use this to now figure out what the hypotenuse is using Pythagorean theorem. Notice that I've got -3 in parentheses. If you square this without parentheses in your calculator, not that you should need to because you should all be able to do -3 squared in your head, it'll give you a negative value. And we all know that a negative times another negative, i.e. squared, is going to result in a positive. So 9, 16, that's 25, equals c squared. We don't care about c squared though, we want to know what c is, so if we take the square root of both sides, it's 5. So our hypotenuse is 5. Now, I can use these values to come up with my trig ratios. If this is the angle, then the opposite side is over here at 4, our adjacent side is -3, and our hypotenuse is 5. Then it's just SOHCAHTOA plus the reciprocal. So opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. Then for our reciprocal functions, you're just going to flip those. At this point, you do want to double check 2 things. One, that the fraction can't be reduced. None of these ones reduce, but let's say it was 4/6. Obviously, that could reduce to 2/3. Or if you have to rationalize the denominator, let's say this was 4 over the square root of 5, you would have to multiply top and bottom by the square root of 5. All right, reference angles. If you had my class last quarter, we did reference angles as part of our trig review unit. Some teachers decided that they didn't need to do it because we were going to do it here. So you're welcome if you had me because you basically know how to do this already. Reference angles, a couple of reminders. One, they're always acute. They're always smaller than 90 degrees. If you get a reference angle that's 90 degrees or greater, you did something wrong. They're always made with the x-axis. One of the biggest mistakes students make is they take a reference angle to the y-axis because they think it's the closest axis, but it's always the x-axis. And they're always positive, much like your PreCalc teacher, always positive, never negative. All right, so 2 examples, just to review. -150. What you might want to do at first is draw these out. You don't have to, but I find it helpful. So if I draw an angle of rotation, this is -90, this is -180. So negative 150 is going to land somewhere in there. Doesn't matter if it's particularly accurate, right? All we need to know is which two it lands between, and then be able to figure out what the distance is to the x-axis. So in this case, the reference angle is what's left right here. And that distance between 150 and 180, or negative 150 and negative 180, is a total of 30 degrees. Radians are a little bit trickier, but there's a way that we can do this when we set up our graph that makes it a lot easier. And if you had me last quarter, you maybe already have seen this if you were paying attention. All right, in radians, a unit circle looks like this. Pi over 2 instead of 90, pi instead of 180, 3 pi over 2 instead of 270, and then 2 pi instead of 360. And we can throw a 0 here because we're starting at 0. This isn't the toughest radian one, but I'm going to treat it like a tough one and show you the strategy I would use if it was a tough one, if it had a weird denominator like 16 or something like that. To make this easier, I'm going to change all of these values so that the denominator matches 4. So they have a common denominator. So that means that instead of pi over 2, this is 2 pi over 4, because 2 over 4 reduces to 1 over 2. Pi is 4 pi over 4. 3 pi over 2 is 6 pi over 4. And 2 pi is 8 pi over 4. Again, because 8 over 4 would reduce to 2. Now that everything's in fourths, it's easier for me to see, all right, I start here, this is 2 over 4, this is 2 fourths, this would be 4 fourths, so 3 fourths has to land somewhere between 2 and 4. And the reference angle is what's left to the x-axis. The difference between 3 over 4, the distance from 3 over 4 to 4 over 4 is 1 over 4, so a single pi over 4. All right, unit circle time. Now, you might have heard a rumor, whatever. You might have heard a rumor that you will have to, on a quiz, fill out a blank unit circle. And that rumor is true. So you will be given one of these to start a quiz. You'll fill it out and then use that to complete the quiz. And that's very true. So what I'd like you to do right now, take a couple minutes, take the blank unit circle that hopefully the sub gave you, and fill this out on your own. And I want you to pay attention to a couple of things, because it looks overwhelming at first, but there's a lot of patterns here. When I get back tomorrow, I'll talk about how you really only have to memorize one quadrant of this, which isn't too bad, and then you just sort of use some patterns to fill in the rest. So fill this in on your own, and I want you to pay attention to some of the couple of things. One, the distance between what I call like a big slice versus a little slice. So the distance when you go from here to here versus here to here, as far as the angles go. So how many degrees for every big slice and how many degrees for every little slice. I'd also like you to pay attention to the patterns with the x and y values. Notice that there's only like 5 different numbers for x and y values. A 1 is 0, a 1/2, a root 3 over 2, and a root 2 over 2. And then it's really just the signs changing. So what happens when you take these coordinates and you move them straight across the graph over here? How do they change? When you move from this one at pi over 3 to this one at 2 pi over 3. And what happens when you move from here at 5 pi over 6 straight down to to 7 pi over 6? What happens to the x and y values there? Those are the patterns that you really want to understand to be able to do this accurately. All right, now that you've got the unit circle filled out, hopefully you paused ratios from the unit circle. So there's some shortcuts here we can take. Sine of theta is going to be the y value from the unit circle. Cosine theta is going to be the x value from the unit circle. Tangent theta is y over x. And then your reciprocal functions are just the reciprocals of those. X over y, like that. To remember this, probably the easiest way that I know is cosine comes before sine alphabetically, x comes before y alphabetically. Tangent, if you can visualize that the vertical is the opposite angle and the opposite side, and the horizontal is the adjacent side, then it's opposite over adjacent still, and then it's just everything flips for the reciprocal ratios. All right, one last thing about patterns. I usually don't show this, but sometimes some students find it helpful. So if you find it helpful, great. It really just talks about the pattern between the signs of the different trig ratios. So all students take calc. If you start quadrant 1, 2, 3, 4, A, S, T, C, this means that the A means that all of the trig ratios are positive. Over here, only the sine ratio is positive because the x values are negative over here. T, only the tangent values because now you have negative over negative, so they cancel out and create a positive for the tangent ratio. And then C, only the cosine is positive down here. All right, one last thing. Just a bunch of examples. So if you want to pause and practice this, and I'm just going to buzz through them quickly. So pause as you need if I start going too fast. Cosine of pi for letter A. You're finding pi. Cosine goes with the x value, so you're taking the x coordinate of the point at pi, right? You're finding the angle here, and then you're taking, in this case, the x coordinate. So cosine of pi is -1. Tangent of 450. Now you've got one that isn't on the unit circle. You could use coterminal angles, or you could think, where would 450 lie if I made an angle of rotation on here? There's 90, 180, 270, 360, another 90 is 450. So 90 degrees and 450 are coterminal. 90 and 450 have the same trig ratios. Tangent is y over x, so our y value over our x value. 1 over 0, it's not 0, right? It's undefined. Sine of 4 pi over 3. Same idea. Find 4 pi over 3, sine goes with the y value, so your answer is the y value from that point of 4 pi over 3. Tangent of 150. Finding 150, right there, it's y over x. Now we're dividing fractions, so we're going to need to use keep, change, flip. The y value is 1/2, so it's 1/2 divided by the x value, -√3 over 2. Dividing fractions, it's keep, change, flip. So 1/2, change it to times the reciprocal, 2 over √3. The 2's cancel out, and it's 1 over -√3. Now I have to rationalize this for full credit. And I rationalize by multiplying the top and the bottom by √3. √3 over √3 would cancel to 1, so I'm not changing the value of this, I'm just changing the way it looks. So -√3 over 3. And our last one, cosecant of 7 pi over 4. Right there. Cosecant is the reciprocal of sine. Sine goes with the y value. So it's the reciprocal of that, negative root 2 over 2. So 2 over root 2, same idea. We're going to rationalize the denominator. 2's cancel out, and it's negative root 2. All right, so take a look at the homework. Give it a shot. It's all review, but come tomorrow with questions if you have them. And I will see you guys tomorrow.